What's up guys, this is Massey. Welcome to another video. In this video I want to give you some examples regarding using chain rule for differentiation. First example, I need to find out derivative of y with respect to x. Y equals to 6u minus 9 and u equals to 1 over 2 x to the power of 4. So dy over dx will be dy over du times du over dx. So dy over du is going to be just 6 du over dx, which is going to be the derivative of u with respect to x, is going to be 4 times 1/2 times x to the power of 3. That's going to be 2 times 12 is 6, 12 x to the power of 3. Next one. Y equals to 2u to the power of 3 and u is 8x minus 1. So again, dy over dx equals to dy over du times du over dx. So the derivative of y with respect to u is going to be 2 times 3 times u to the power of 2. Because you know a to the power of a times u to the power of n. When you find out the derivative is a times n times u to the power of n minus 1. So we have 6 times u to the power of 2 times derivative of u with respect to x, which will be just 8. So 6 times 8 is 48 u squared. And u is 8x minus 1. So it's 48 times 8x minus 1. Next example. Y equals to sine u. U equals to 3x plus 1. We need to find dy over dx. We can say dy over dx equals to derivative of y with respect to u times derivative of u with respect to x. So it is going to be cosine u times u prime, which is going to be 3. So it's going to be 3 times cosine u, and u is 3x plus 1. 4. It's going to be y equals to cosine u, u equals to negative x over 3. Dy over dx equals to dy over du times du over dx. Derivative of y with respect to u is going to be negative sine u times derivative of u with respect to x is going to be negative 1 over 3. So negative times negative positive 1 over 3 sine u or sine negative x over 3. Next example. Y equals to cosine u and u equals to sine x. So we need to find dy over dx, which will be equal to dy over du times du over dx. Derivative of y with respect to u is going to be negative sine u. Derivative of u with respect to x is going to be cosine x. So it is going to be negative sine of sine x times cosine x. Next one, 6. Y equals to sine u, u equals to x minus cosine x. So derivative of y with respect to x is going to be derivative of y with respect to u times derivative of u with respect to x. Derivative of y with respect to u is going to be cosine u times du over dx. Du over dx is going to be 1 minus negative sign, which is going to be plus So it's going to be cosine u times 1 plus sine x. Or you can say cosine of x minus cosine x times 1 plus sine x. Why did I write it like that? Because u is x minus cosine x. Next example, 7. Y equals to 10u, u equals to 10x minus 5. So dy over dx equals to dy over du times du over dx. So derivative of tan is going to be secant squared of u times d over dx is going to be 10. So it's going to be 10 secant squared u, or instead of u I can write 10x minus 5. Next one, 8. Y equals to negative secant u, u equals to x squared plus 7x. So dy over dx will be dy over du times du over dx. So derivative of y with respect to u is going to be negative secant u times tan u, that's the derivative of secant, multiplied by du over dx. Derivative of u with respect to x is going to be 2x plus 7. So we're going to have negative secant x squared plus 7x times tan x squared plus 7x times 2x plus 7. So basically I wrote the same thing here, but instead of u I wrote x squared plus 7x. Next example, y equals to 2x plus 1 to the power of 5. We need to find dy over dx. So again, it's like u to the power of 5. When you find out derivative, is going to be 5u to the power of 4 times u prime, derivative of u with respect to x. So it's going to be 5 times 2x plus 1 to the power of 4 times derivative of 2x plus 1, which is 2. Then when you rearrange it, 2 times 5, 10. 10 times 2x plus 1 to the power of 4. 10. Y equals to 4 minus 3 to the power of 3x to the power of 9. So same format. When you have u to the power of n, or let's say a times u to the power of n, when you find out the derivative, if we assume that u is a function of x, the derivative will be a times n times u to the power of n minus 1 times u prime. So dy over dx will be 9 times 4 minus 3x to the power of 8 times derivative of 4 minus 3x, which is negative 3. It's going to be negative 27, 4 minus 3x to the power of 8. Next one. Y equals to 1 minus x over 7 to the power of negative 7. dy over dx will be negative 7 times 1 minus x over 7 to the power of negative 8 times negative 1 over 7. So when you multiply these two, negative 7 times negative 1 over 7 is going to be positive 1. So they cancel out. You can have 1 minus x over 7 to the power of negative 8. Next one, y equals to x over 2 minus 1 to the power of negative 10. So dy over dx will be negative 10 times x over 2 minus 1 to the power of negative 11 times 1 over 2, which is the derivative of this expression. 10 times negative 1 over 2 is going to be negative 5, x over 2 minus 1 to the power of negative 11. Next one, x squared over 8 plus x minus 1 over x to the power of 4. dy over dx will be 4 times x squared over 8 plus x minus 1 over x to the power of 3. We need to subtract the 1 times the derivative of this part. It's going to be 2 over 8 times x, so which is going to be x over 4. Derivative of x is going to be 1 plus 1 over x squared. That's the derivative of this function. Next one. Y equals to x over 5 plus 1 over 5x to the power of 5. dy over dx will be 5 times x over 5 plus 1 over 5x to the power of 4. Then multiply by the derivative of this part. Derivative of x over 5 is 1 over 5. Derivative of 1 over 5x is going to be negative 1 over 5x squared. And then we can multiply this one by this expression. It's going to be 1 minus 1 over x squared times x over 5 plus 1 over 5x to the power of 4. Next one. Y equals to secant of tan x. dy over dx will be, the derivative of secant is secant x times tan x. Derivative of secant u is going to be secant u tan u times u prime. And derivative of tan u is going to be secant squared u times u prime. So we have the same thing here. Derivative of secant is going to be secant of tan x times tan of tan x times the derivative of tan, which is going to be secant squared x. So if I write it again, it's going to be secant of tan x times tan of tan x times secant squared of x. So this is the final answer. I hope you enjoyed this video. Please leave me a comment if you have any question and I'll get back to you as soon as possible. Please don't forget to subscribe this channel. You can have access to many other videos regarding chain rule, implicit differentiation, and other topics in calculus and physics and chemistry. I will leave some related videos and playlists in the description in case you need extra practice questions. Thank you for watching and have a great day.